All right, welcome to another deep dive. And today, today we're diving into ONNX Runtime.
ONNX Runtime.
Yeah, it's this super interesting technology. I mean, it's making waves in the AI world.
It is.
And I'm really excited to dig into this. So we're going to be looking at a blog post by Kevin Lagerberg. I hope I said that correctly.
You got it.
Okay, great. And he really seems to know his stuff in this area.
He does.
And what's got me so intrigued about this whole thing is this idea, right, that you could take an AI model, any model really, and use it on basically any device.
Yeah, anywhere.
It shouldn't matter.
Any device.
You built it in PyTorch or TensorFlow, it just works.
Exactly. It's pretty groundbreaking stuff. And Kevin does a great job in the blog post at explaining this idea of ONNX Runtime acting like a universal translator for AI model.
Universal translator. Okay.
Yeah. So, let's say you've trained a model using Python and PyTorch, your typical tools, right?
Yeah.
ONNX Runtime lets you take that same model and run it smoothly on Windows or Linux.
Wow.
You could even deploy it on a mobile phone or in a web browser.
Whoa. Really?
All without having to rewrite tons and tons of code.
Okay. I mean, that's super convenient. I get that.
Right.
But wouldn't developers, wouldn't they already have ways to make their models work on different platforms?
Yeah.
What makes this universal translator idea so revolutionary?
Think about it. Think about the early days of the internet.
Okay.
You had, all these different website coding languages and browsers.
Yeah.
Nothing worked together seamlessly. It was a mess.
Yeah.
But then standardized languages came along, like HTML and CSS.
Right.
And suddenly building and viewing websites became so much easier. ONNX Runtime is doing that for AI, bringing a level of standardization that just wasn't there before.
So it's not just about convenience for developers then. No. It's about making the whole AI ecosystem more connected.
Absolutely. And it unlocks so much potential for developers. This write once, run anywhere advantage is huge. Yeah. Less time wrestling with all these compatibility issues.
Yeah.
And more time actually improving their models and building new applications.
So how does that look in the real world? Can you give me an example?
Sure. Imagine a company developing a cutting-edge AI model for medical image analysis, right?
Okay.
With ONNX Runtime, they could deploy that model in a high-tech hospital.
Right.
On, powerful servers, on a doctor's tablet at the bedside, and even on a patient's smartphone for remote monitoring, all without having to rebuild the model from scratch.
Wow. Okay. That's a really compelling use case.
Yeah.
It sounds like this could significantly speed up the development of AI solutions. In so many fields. But how does it actually work? How does it work on a technical level? What makes ONNX Runtime so efficient?
So remember that universal translator analogy we were talking about?
Yeah.
ONNX Runtime doesn't just translate, it optimizes. It takes your model, right?
Right.
And fine-tunes it for the platform it's running on.
Okay.
One way it does this is through these things called execution providers.
Execution providers,
yeah. Think of them as specialized processors.
Okay.
Each one's designed to handle a very specific type of task.
So instead of a one-size-fits-all approach,
right,
ONNX Runtime uses the best tool for the job.
Exactly. For example, if your model is running on a device with a powerful NVIDIA GPU, ONNX Runtime will use that.
Mm-hmm.
But if it's running on a low-power mobile device, it'll switch to a different execution provider.
To save battery.
Exactly.
That's really clever.
It's happening all behind the scenes.
Yes.
So developers don't have to worry about it.
Okay. This all sounds pretty amazing.
It is.
But I'm sure there's some limitations with ONNX Runtime.
Yeah.
Right. No technology is perfect.
Of course not.
What are some of the things that developers need to be aware of?
Well, one thing is that converting a model to the ONNX format isn't always easy,
Okay. Yeah.
It's kind of like trying to translate a complex poem into another language.
Okay.
You can get the general meaning across, but some of the nuances might be lost.
So you need to make adjustments to the model sometimes.
Right.
To make sure it translates well.
Exactly. Especially with very complex models.
Mm-hmm.
The good news is that the ONNX community is always, they're always developing tools to simplify this process.
That's good. I also remember Kevin mentioned something in his blog post called a dynamic graph limitation.
Yeah, dynamic graphs.
Can you explain what that is?
Sure. So think of it this way. A lot of AI models work with a fixed structure. They take an input, process it through a set of predefined steps,
right,
and produce an output, right? Kind of like following a recipe.
Okay.
But some AI models, especially those used in cutting-edge research, they're more dynamic. They change their structure on the fly, you know.
So it's more like improvisational cooking.
Exactly. More like improvisational cooking. And for those models, ONNX Runtime might not be ideal.
Got it. That makes sense. So we've talked about the advantages, the efficiency and some of the challenges.
Right.
But where is this being used in the real world? Are there applications of ONNX Runtime out there right now?
Oh, absolutely. One of the biggest examples is Microsoft.
Microsoft.
Yeah, they're using ONNX Runtime in a lot of their products and services.
Really? Like where?
Well, think about Bing. Right?
Bing, okay.
Bing search results get smarter and more personalized all the time.
They do, yeah. It's kind of spooky how well it seems to know what I'm looking for.
Right. Well, a lot of that is thanks to ONNX Runtime.
Oh, wow.
It lets Bing deploy these complex AI models that personalize those results based on your browsing history.
So ONNX Runtime is behind those lightning-fast search results.
It is.
Okay, wow. What else is it being used for?
It's also powering a lot of the AI features you see in Windows and applications like Office.
Oh.
For example, some of the smart editing features in PowerPoint.
Yep.
Or the real-time translation in Word, those are all powered by ONNX Runtime.
Wow, so it's really embedded in a lot of the technology we use every day.
It is.
And it sounds like it's not limited to just Microsoft.
No, not at all.
What other examples are there?
Oh, tons. Companies are using ONNX Runtime for everything from facial recognition in mobile apps to detecting fraudulent transactions in finance. It's even being used to analyze medical images in healthcare.
That's amazing. It's like ONNX Runtime is quietly towering this AI revolution all around us.
It really is.
And to think it all started with this idea of making AI models more portable.
Yeah, more accessible.
More accessible.
It's remarkable. And the best part is that it's open source.
Yeah.
Anyone can use it. Anyone can contribute to it, help shape its future.
I'm officially fascinated by this.
Good.
So we've got this incredibly powerful and versatile tool that's already being used in so many different ways. What's next for ONNX Runtime? Where do we go from here?
That's a great question, and that's what we should dive into next.
Okay, sounds good.
There are a lot of exciting developments on the horizon. So we've talked about how ONNX Runtime is already having a pretty big impact. But what's really exciting is its potential to change the AI landscape even more, I think, in the coming years.
Okay, I'm all ears. What kind of advancements are we talking about here?
Well, it's a bit of both, actually. On the efficiency front, one of the key areas of focus is optimizing ONNX Runtime for the ever-evolving world of hardware.
Right.
We touched on execution providers earlier.
Yeah.
And as new hardware platforms come out, like specialized AI chips, more powerful mobile processors, even, quantum computing down the line.
Whoa, okay.
We're going to need new and improved EPs to really harness those capabilities.
So it's like a constant race to keep up with the latest and greatest in hardware.
It is. It definitely keeps things interesting.
Yeah.
The ONNX community is really active in this area, but it's not just about speed and efficiency. There's also a lot of work being done to expand the types of AI models that ONNX Runtime can work with effectively.
Right.
We talked about the challenges with those dynamic models earlier.
Yeah.
And this is an area where I think we'll see a lot of progress.
That makes sense. As AI research keeps advancing, the models just become more complex.
They do.
It's crucial that ONNX Runtime can keep pace.
Absolutely. And then you've got the whole area of model optimization, right?
Yeah.
ONNX Runtime already does a pretty good job at optimizing models for different hardware, but there's always room for improvement.
Of course.
Researchers are developing new techniques all the time to make models smaller, faster, more energy efficient without sacrificing accuracy.
So it's like getting more bang for your buck.
Exactly. And this is huge, especially for deploying AI on on resource-constrained devices like smartphones or even tiny sensors.
So you're talking about like a truly interconnected world.
Yeah.
Where AI is everywhere.
AI is everywhere.
But wouldn't that require like a massive amount of standardization?
You're absolutely right. Standardization is key here, and that's where the ONNX community really comes in. Right. By working together, developers, researchers, industry experts, they can ensure that ONNX Runtime remains this robust and versatile platform for AI.
It's like a global collaboration to build a foundation for this future powered by AI.
Precisely. And one of the exciting parts of this collaboration is the ONNX Model Zoo.
The Model Zoo?
Yeah, the Model Zoo. We touched on this earlier, but it's worth digging into a little bit more.
Okay.
Imagine this massive online library filled with pre-trained AI models.
Oh, wow.
All ready to be used with ONNX Runtime.
So instead of starting from scratch,
right,
developers could just grab a model from this Model Zoo and adapt it to their needs.
Exactly. It's like having this library of building blocks for AI.
Right.
You could grab a model for image recognition, natural language processing, even medical image analysis, and then tweak it to fit your application.
That could really democratize access to AI.
It could.
And speed up the development of new solutions in so many different industries.
Absolutely.
Are there any downsides to having all these pre-trained models, so readily available?
That's a great question. Like any powerful tool, pre-trained models need to be used responsibly, right? There's always a potential for misuse. For example, a model trained to detect certain patterns in images could be used to create deepfakes or spread misinformation.
So it's important to have safeguards in place.
Absolutely. The ONNX community is very aware of this, and they're working on developing guidelines, best practices for the responsible use of these models.
So it's this constant process of balancing the potential of AI
right.
with the need to mitigate the risks.
Exactly.
This all seems incredibly complex.
It is.
It's clear that ONNX Runtime isn't just a piece of software. It's a whole ecosystem.
It is. It's dynamic. It's evolving rapidly. That's what makes it so fascinating.
Yeah.
There's a real sense that we're just scratching the surface of what's possible.
Okay, so we've covered the future of hardware, the expansion of model capabilities, the importance of standardization,
right?
The Model Zoo. Is there anything else that we should be paying attention to?
There's one more thing I think it's worth highlighting, and that's the growing importance of the edge.
The edge. What do you mean by that?
So it's all about moving AI processing closer to the source of the data.
Okay.
Instead of sending all the data to the cloud, we're seeing more and more AI happening directly on devices at the edge of the network. Think smartphones, smart speakers, even industrial sensors.
I see. So making AI more distributed.
Exactly. And ONNX Runtime is perfectly positioned to play a key role in this shift towards edge computing.
Okay.
Remember all those optimizations we talked about?
Yeah.
For efficiency, resource-constrained devices, they become even more important when you're running AI on devices with limited power.
So ONNX Runtime is not just a bridge between AI frameworks.
Right.
It's a bridge between the cloud and the edge.
That's a great way to put it. And this trend towards edge AI is only going to accelerate as the demand for real-time AI applications grows.
Yeah.
And the number of connected devices explodes.
Right.
ONNX Runtime is going to play an even more important role in making AI, ubiquitous.
Okay, this is really exciting stuff. I'm starting to imagine this future where AI is seamlessly integrated into our lives, powering everything.
It's coming. It's closer than you think.
So to sum it all up, we've got this incredibly versatile technology.
Yeah.
It's already making a big impact.
It is.
But it's also evolving really rapidly.
Yeah.
And on top of that, it's playing this key role in this shift toward edge computing.
Absolutely. It's more than just a technical tool. It's a catalyst for innovation.
Yeah.
A driver of progress, a force shaping the future of AI.
I'm completely captivated by this. But before we wrap up, is there anything else you think our listeners should know about ONNX Runtime?
Well, one thing I really want to emphasize is that ONNX Runtime isn't a static technology. you know?
Right, right.
It's constantly evolving and improving, and it's driven by the tireless efforts of the ONNX community.
That open source spirit is really inspiring.
It is.
It feels like this collective effort to push the boundaries of AI and make it more accessible to everyone.
It is, exactly. And that's why I encourage anyone who's interested in AI, whether you're a seasoned developer or just starting out, to explore ONNX Runtime, see how you might contribute to its growth.
That's a great call to action. So as we dive deeper into this world of ONNX Runtime, what are some of the challenges that lie ahead?
Let's delve into that next. There are some key areas that really need to be addressed.
So we've talked about the amazing potential of ONNX Runtime and how it's it's poised to revolutionize the AI landscape. But like with any groundbreaking technology, there are bound to be some challenges along the way, right? What are some of the hurdles that the ONNX community needs to overcome to really unlock the full power of this tool?
Yeah, that's a great question. And it's important to acknowledge that the path forward isn't always, smooth sailing.
Right.
One of the big challenges, I think, is striking a balance between standardization and innovation. Huh. The beauty of ONNX is that it brings order to this often chaotic world of AI frameworks, right?
Yeah.
But the field of AI is constantly evolving with new model architectures and techniques emerging all the time.
So how do you keep up with this rapid pace of innovation without sacrificing the standardization that makes ONNX so valuable?
Yeah, it's a constant juggling act for sure.
Yeah.
The ONNX community needs to be agile and responsive, constantly expanding the standard to accommodate these advancements.
So it's not a set it and forget it kind of
thing. No, not at all.
ONNX needs to be this living and breathing ecosystem, right?
Exactly. And this evolution needs to happen on multiple fronts, right? We talked about optimizing ONNX runtime for new hardware platforms. But it's not just about keeping pace with the latest chips and processors. Yeah. It's also about anticipating future trends and making sure that ONNX runtime is ready for whatever comes next.
Like what kind of future trends are we talking about?
Well, one area that's generating a lot of buzz these days is quantum computing.
Quantum computing.
Okay. While it's still early days, the potential for quantum computers to revolutionize AI is immense.
Yeah.
Imagine being able to train and run AI models that are orders of magnitude more complex and powerful than anything we can do today.
That sounds like something straight out of science fiction.
Yeah.
But if quantum computing does become a reality, how would ONNX Runtime need to adapt?
That's a question that researchers are already thinking about.
Yeah.
Quantum computers work on completely different principles than classical computers, so the way we design and execute AI models is going to need to change dramatically. ONNX Runtime would need to incorporate new execution providers and optimization techniques, specifically for quantum hardware.
So it's not just about like adding a new feature or tweaking some code.
Yeah.
It's about like fundamentally rethinking how we approach AI development.
Absolutely. And that's what makes this field so exciting.
Yeah.
We're not just building tools, we're shaping the future of intelligence itself.
Okay, so quantum computing is a big one.
Yeah.
What other challenges are on the horizon?
Another area that needs constant attention is security.
Okay.
As AI becomes more integrated into these, critical systems, healthcare, finance, transportation, the stakes for security breaches become much higher.
Right.
We need to make sure that ONNX runtime is robust and resilient to attacks.
So it's not just about making AI work, it's about making sure it works safely.
Exactly. And this involves thinking about security at every level, from the design of ONNX runtime itself to the way models are converted and deployed.
So it's a multifaceted challenge.
It is.
That requires expertise from different disciplines.
Absolutely. And it's an area where collaboration is essential, I think.
Yeah.
The ONNX community needs to work with security experts, identify potential vulnerabilities, and develop strategies to mitigate those risks.
It sounds like the future of ONNX Runtime hinges not just on technical innovation,
right,
but also on responsible development.
Yeah.
And a commitment to building a secure and trustworthy AI ecosystem.
You couldn't have said it better. At the end of the day, the success of ONNX runtime depends on Birla trust.
Yeah.
The users need to feel confident that the technology is reliable, secure, and ethical.
It's like building a house.
Yeah.
You need a strong foundation and sound construction principles to create something that people feel safe and comfortable living in.
That's a great analogy. And just like a well-built house, ONNX Runtime needs to be able to adapt and evolve over time to meet the changing needs of its occupants.
So as we wrap up this deep dive into ONNX Runtime,
yeah,
what's the key message you want our listeners to take away?
I think the most important message is that ONNX Runtime represents this fundamental shift in the way we develop and deploy AI. You know, it's a powerful tool that's breaking down barriers, fostering collaboration, democratizing access to AI. But it's also a journey, not a destination.
A journey with its share of challenges and obstacles.
Yeah.
But also with incredible opportunities for growth and innovation.
Precisely. And it's a journey that I believe will ultimately lead us to a more intelligent, more connected, and more human-centric future.
Well said. Thanks for joining us on the deep dive.
It's been my pleasure.
And for sharing your insights on this fascinating and rapidly evolving field. It's been a truly eye-opening exploration of ONNX Runtime and its potential to shape the future of AI.
It's been a pleasure. And to our listeners, keep exploring, keep questioning, keep pushing the boundaries of what's possible with AI. You know, the future is waiting to be built, and ONNX Runtime might just be the tool that helps you build it.
That's a great point to end on. And that is it for today's deep dive. We'll be back next time with another fascinating topic in the world of AI and technology. Until then, keep learning, keep exploring, and keep innovating.